Ayo, 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 ayo. What's up? What's Gucci? What's poppin'? You already know who it is. It's Key. I'm back for episode number 3. It's a stream. You know what I'm saying? GoLang. Um, Back. Happy to be here. Um, Today we got some new stuff going on. I'll be continuing my GoLang introduction. I don't know how long this introduction is going to be or how many parts, to be honest with you. I'm just going to go with it. I'm going to go until I feel like I done been introduced to the thing. And that could take as long as it's going to take. I don't really know. At what point has introduction ended? I feel like maybe once I have covered all of the basic things that I need to make an app, then maybe my introduction will be over. I really don't know. Um, That's beside the point. Let's go ahead and drop into today's stream. I don't know how long I'll be on here. It is a Friday night. I ain't got nothing else to do. I got some plans this weekend and tomorrow, but tonight it's just me and you. Okay, we just go do this. So go ahead and get you some protein shake. This is protein ice cream. I made it too thick. Get your computer, whatever you want to do. Just come hang out. Hang out with your boy. Okay. This is GoLang intro number 3 for OpenPair. This is continuing my deep dive into GoLang. So the backstory behind this is that I've been a programmer, a professional programmer since 2018. I've been coding, even before that I was coding. And GoLang is something I've always been interested in, and I've kind of dipped in and out of it. My main stack is more of like the Node, stack, JavaScript, Node, Express, that kind of stuff. And I've been doing that, or whatever. GoLang has kind of always been in the backdrop. I've done a little Python. I actually really like Python a lot, but I've never really had a chance to sink my teeth into GoLang. And also, I have not had a chance to really sink my teeth into a language that has more low-level access and traits. So GoLang is kind of that for me. Oh yeah, I also did some Java development, Groovy, and some like Scala stuff too. But this right here is my pretty boy swag. Um, and so, anyways, today we're going to be looking into structs and methods, interfaces. We already covered structs, methods, and interfaces, but I just need like another. I'm going to keep revisiting things until I feel more confident with that's how it's going to be. The new things are going to be concurrency and testing, and then there's going to be some error handling here too. So concurrency is something I have not dealt with in testing. And then what I'm thinking is that, the next stream will hopefully get to touch on pointers. I'm actually really excited about pointers. It's something that I have avoided for a while, and I feel like it's getting that time where I just need to dig deep and get into it. So, anyways, this is the agenda today. If you're interested in following along or you're interested in this repo, in this code that I write today, all you have to do is go down below into the description for this live stream, and there is a link. I will probably always post a link to the repo that you can follow to join me. At least as far as like these introductions go. I may be working on other things in the future where I may not make a repo available. So I'll let you know. I'll just go down there and look. Okay. So this is the repo. I'll push up the code whenever I'm done with the stream. Okay, so I got it loaded up here. The first thing I need to do actually. Last thing. I always want to say this. Well, I'm not always going to say this, but right now I try to make this a point. I am not making this up out of the top of my head. I am not as experienced with GoLang as I would like to be. And so this is learning for me. A lot of the stuff that I'm studying is based on recommendations that I have got from using ChatGPT to help me construct a course of self-learning. I am not using AI to write my code for me, but I am using it to provide guidance, and I'm using it to provide a structured approach for topics to learn. And you can see here I have some example code that I'm going to be using as reference. but I'm going to be writing this code in today's repo by myself and using my reference as guidance as I explore that and play around with it. Okay, so I'm not going to be not going to be copying and pasting code into here. I'm not going to be using Copilot or anything like that, but I just want to be straightforward because I believe that AI is a really powerful tool for learning. And I believe that if you use it correctly, it can help immensely, especially when it comes to learning skills and needing to have things explained to you in a certain way. Love to use it for a good comment. Love to use it to help me interpret documentation. But my belief is that a huge part of becoming proficient in anything is just the repetition, manually typing in things, struggling. I believe that those are all things that help you grow and become an expert. And no amount of AI is going to do that part of the learning journey for you. So as much as it plays a role into helping me figure out what to do and what to focus on, I still always come back to this, and I always make it a point to manually make the thing, even if I use a little bit of AI to help me figure out what to make. Does that make sense? Okay. You don't have to agree. You don't have to do what I do. This is me trying to be transparent with you. I don't want you coming over here thinking I'm an expert. Okay. If I was thinking about all this stuff out the top of my head and just doing it, I wouldn't be on here. I'm just going to be straight up with you. I wouldn't even be on here if I really had it like that. So, okay, that's my preface. I'm gonna have to probably just like write up something and put it in the description in the future because I feel like I don't want to take up time saying it every single time. But I know somebody will come over here and not get it. So it's my little discretionary warning. Okay, so we could jump into this now. Let me just get my notes up here. Okay. Okay, so first thing I need to do is make a main.go file. In order to run my Go code, you need to have a main.file, which is the main file that gets executed when you run your application. So we're going to do touch main.go. And we're going to go into here and set package to main. I already have my Go mod file set up. This is a file that's more or less a configuration file comparable to package.json. It contains your configurations. Something I'm going to get into later on is a make file. Make file is how you can make like little scripts and stuff, store scripts and automations and whatnot. That's probably going to be its own video at some point. So that's not here. I don't have any build or scripts files or anything like that. It's just straight up running my file here. In fact, let's go ahead and try to get this file running so we can make sure it works, which that's just me being paranoid. I always do. I'm always saying that, like, make sure the thing works before you start trying to write a bunch of code because you know feel real crunchy if it doesn't. So let's go ahead and do a console log or a print file. So fmt.print line. Oh, we need a main function. So in your main.go, you need a main function. Oops. And you need to have that because that's what actually is going to run in the file. And then we could have fmt.print line, and we could just say main.go is running. Oops. I shouldn't have did that. Oh, I'm glad that didn't overwrite. We need to do run go period or go run period. Okay, there you go. So main go is run. It isn't running. It more or less rant, but that's in the past tense. So my language is off there. Okay, so there is. Okay, I'm gonna need two dependencies for this. I'm going to need format and I'm going to need time. I'm just going to go ahead and import both of them so I don't have to worry about it later on. But to do multiple imports, you have to do in the parentheses. They're not comma separated, but they are on separate lines. So, and I need time here as well. Okay. And what I'm going to do is I'm going to use this main function as a place to run the main code, but I'm going to do things like building functions and whatnot on the outside, building functions and structs and methods outside of this main function. Before I get too deep into this, let me go ahead and set a timer. Hey Siri, set a timer for 30 minutes, and then I'm going to take a break in 30 minutes, and I'm going to come back after that. So hopefully this stream won't last any more than pop. Hey Siri, set a timer for 2 hours. Okay, I was about to say, don't do me wrong. Don't do me wrong. Okay, so yeah, this stream shouldn't take anything more than 2 hours. That's my plan. So I'm gonna take a little break a couple times at least. Okay, so the first thing I'm gonna do here is I'm gonna work on structs and methods. So demonstrating structs and methods. Okay, so I'm gonna work on a struct for a dog. And this dog is going to be created from I'm sorry, this is going to be a struct called animal. And I'm going to use animal to make different types of animals. And one's going to be a dog and one's going to be a cat. So we're going to make a struct for a dog. And we're going to make we're going to use a struct to make a dog. And we're going to call this an animal. And we're going to use the same exact struct to make a cat. So we're thinking about a struct as being a generic classification and a cat or a dog as being a specific type of animal. Okay. Okay, so, man, I'm definitely going to it's going to take me a while to get this struct name, to be honest with you. Like making a basic struct is relatively easy, but it's just like manipulating it and all the other stuff you do is just like, it's so different from what you used to. Okay, so the animal struct will hold additional fields like name and age. So type animal struct, and then we have name, which is going to be a string, and then we have age, which is going to be an integer. Okay, so let's go ahead and use this struct to make a dog. We're going to assign this to a variable, so dog, and we're going to use the animal struct, and then we can pass into it the values for the two properties. I think they're called properties. So we got name, dog, and then we have age, and this age is going to be 7. Okay. And then we're gonna print this to the console, and we're gonna say dog.name. So it's just like printing from a map, basically. Oops, I shouldn't have did that. Okay, we're just gonna do dog.name for now. I'm gonna put a little message up here. I like to have some type of console string anytime I'm logging some data structure. Okay. And then we can do the same thing with the cat. Let's just go ahead and copy this and we can just edit it. So cat. Oops. And then we'll change this down here to cat. And then cat. And cat, how old is my cat? 4 years old. No, she's more than 4 years old. She's like 6. Okay. So let's go ahead and run this. Oh, you cannot have a dependency that you're not using in GoLang. It does not like that. I forgot that. I don't like that, to be honest, but I get it. I get how it keeps your code clean, but it's like, calm down. It's not a big deal. Okay. I'm gonna actually give my cat and dog a different name. Well, no, I'm gonna leave it. Okay, so um, that works. The other thing that you can do is that you can actually add methods on these structs so that the method is something that can be called just like how you can call one of these properties. Let me just look something up real quick. I need to know if they're called properties. GoLang struct. I don't want to use the wrong word. Okay, it's called a field. It's called a field. Okay. Let's go ahead and put that in our notes here because I'm definitely going to want to remember that. And fields can be named or anonymous, meaning it can just be a value in there, or it can have a name associated with it. Okay, I'm not sure what situation you would use like an unnamed value. I'm gonna have to look into that, but I'm not gonna do that today. I'm just gonna keep it simple today. Okay, so um, we can make a method for a struct, and this method, the method we're going to make is we're going to allow for each animal to have its own specific response or like uh, sound as animals tend to have. So we're going to dynamically change the behavior of our uh, animal struct based on the name. Based on the animal's name. Okay, so to do this function a animal, and then this lowercase a is it's like a way that we can refer to whatever struct this is being used on within the block that defines the method's behavior. And this method is going to be called speak, and it's going to return a type of string. Let me write my notes here. So a is it's a reference within the method to the struct. And I need to test that out actually. So what I'm going to do is I'm going to fmt dot print line, and I'm going to say my animal is a dot name. Okay, so whenever I use this in a second, I expect this a to actually be a reference to whatever animal is using this method, which is going to be built into this. So this is like a way to attach it. So I'm kind of like used to like constructors and classes as a way of creating methods that exist on something, but this is interesting. Okay, so to make this work differently for each animal, let's make a switch statement. and the switch statement is going to use a.name, and we can make a series of cases. So when it is dog, then dogs will go wolf. And then case, do I need to do anything? Okay, I don't have to do anything after the return. Okay, so case, and then when it's a cat, return mew mew. My cat actually does not meow. She goes rawr, like she's been smoking 40 packs of cigarettes a week for the past 20 years. Okay, so if the animal is a cat, it'll go mew mew. And then we need a default. So what happens if it is neither or something else? Return unknown animal. And that's the default case for others. Oh, excuse me. Okay. So to actually use this, let's go ahead and go down to our console messages here, and let's just add dog.speak now, and we should see that this will add a string to our console message for my dog, and that will that will show up down here. Let me add actually like an extra line here because I want my consoles to be spaced, so it's less crowded. So let's do fmt print line. I'm gonna do a space at the top and at the bottom because I'm a little nitpicky like that. Okay, so let's go ahead and run this. I can see that my dog goes wolf wolf, and I can also see that the my animal message here is showing up. So that's cool. I'm gonna actually comment that out right now. Actually get rid of it. I don't really need it. But that's cool. So this lowercase a is a reference to whatever instance of the constructor you're using to call the method. It's like using this in JavaScript. Okay. So let me go ahead and do that for my cat as well. And let's run that. Cool. Okay, so what's next? We're going to make a slice now, and we're going to use this slice to hold our animals. I don't know. I have this in my notes, but I don't quite understand it. So I'm going to do this. To be honest, I'm just going to play around with it. So it says here, implementing the mover interface in animal struct. And this is going to be, oh, okay, so this is interfaces. I don't think I understand the difference between an interface and a struct. I know what an interface is in TypeScript, but I don't think I know what an interface is. Huh, okay. By the way, I did not look at this before I started working on this today. I just sort of more or less jumped up on it here, which is cool. Sometimes it's like that. Okay, so interfaces and Go, and then we're going to make an interface called mover interface, and this will have a single method called move. Okay, and then after that, we're going to implement the mover interface in the animal struct. This allows instances of animals to be treated as movers. So I think what this means is like I'm making a new a new category that will inherit. Actually, I don't want to guess. Let me just look it up. Let's look this up. So a struct is a type which contains named fields. Okay. Yep. Okay. Okay. Or interfaces. Oh, okay. So um, interfaces are to methods what structs are to fields. It's just a way to store a bunch of methods that can be attached to a struct. No, no, no. It's just a list of methods, basically. And so a struct is a list, is a collection of different fields that can be used to make an instance of something. And then a interface is a set of methods that can be attached to a struct. So, like in this case, in this previous situation, we're creating one method that we're directly attaching to the struct animal. But what if we want to have a set of them? I'm assuming that that's what's going on here. So we're going to test this out by actually writing the code. So type mover interface, oops, and then move string. And this is, I'm assuming, the return type of this new method, which is going to be called move. Um, okay. Something about this is feeling weird to me. So function a animal, and then the method's name is move string, and this is going to return a.name plus is moving. Okay. Mm-hmm. Okay, let me look at this a little bit more. Okay, so this right here is spreading in a this is spreading in some um, methods here for total area. Let me look at a different website. Oh, that's the same thing. Let's check this out. Ooh, this is small. What does that say? Okay. Structs, composite data type, define new types, can have methods, interfaces, contract of methods. Okay, that made sense. Define behavior, only method signatures. Okay. In GoLang ecosystem, structs are central. They provide a mechanism to group together variables of different data types, essentially allowing the creation of custom types. Their primary function is to define and represent complex data structures in GoLang, in the Go language. Basic syntax of Go. Okay, cool. Okay. Let me just copy this here and put this in my notes. I was telling some of my students earlier, I was like, if you are going to write your notes out anyways in a separate document, why not just put them in your code? If you're like, learning and stuff like that, why not just put them in the code? You know what I mean? I mean, I'm sure there are reasons and situations when you shouldn't, but it's just like, that's a good question to ask. Why not just put them here? Makes sense. Okay, so this is the use of a struct. So you could also do like the new method or the new function and put the struct in there as well with the definition. But I think this also works. Okay, and then you can assign the fields or you can access them. Oh, wait, can you assign them? Or I don't know if you could reassign them. Oh, you can embed structs. Okay, cool. Okay, so interfaces. Interfaces are a foundation concept. They provide a way to define the behavior that types must fulfill, acting as a contract or a set of methods that a type should implement. Unlike other languages where interfaces are often tied to classes, Go interfaces focus purely on method signatures. Okay, so they provide a way to define the behavior that types must fulfill, acting as a contract or a set of methods that a type should implement. So that means to me, at least, that this is like an agreement. If something does not have these attributes or these methods, rather, then it should throw like some type of error, maybe, or it should signal something negative. I would imagine. Um, that's what I'm getting at least. Okay. Oh, let me move this. Okay. Oh, you know what? I forgot I had this. Better comments is for some reason I sometimes don't want to use it because I for some reason imagine a world in which I will not have access to better comments, but that has never happened. That it ends up just being an excuse to not use better comments. Um, I need the little cheat sheet for it. How do I signal? Oh, I just do a star. Okay, let's just do a star. No, I like the way this stands out more for this color scheme. Okay. Interfaces provide a way to define the behavior that types must fulfill. So this is an interface, and then I'm saying that this animal must have this behavior, and so therefore I'm attaching this behavior to the animal. But then there must be something else that happens afterwards. So I think that's what this next part of my little thing is for. So demonstrating interface usage with a slice of interfaces. my brain is like slowly making sense of this, and it feels really nice. Okay. And this apparently is how you can use interfaces to handle a collection of different, I gotta scroll, of different types uniformly. Okay. Okay, so for this, we're going to make a new method or a new function. So func process animals, and then we're going to give it animals, which is, that's going to be the argument, and this is going to be, assuming that, okay, I think I get what's happening here. We're going to give it animals, and animals is going to be, have an interface type of mover, which means that all animals that come into this function need to have the methods or the behaviors that align with this mover interface. And that means that it has to have this move method on it. And if it doesn't, then I guess it would not be compliant to work with this function process animals. That's what I'm assuming. So anyways, let's do our for loop. So for the underscore, I'm assuming here is a way to indicate a because we're destructuring for this for loop, we're destructuring something and also animal, but I'm assuming that this first part here is just because we're not going to use this first variable. I'm not really sure actually. I could look that up later on. So we want to do the range of animals. So we're going to say for all animals, and I'm not sure where animals is going to come. Oh, that needs to be lowercase. Okay, now I know. So for all animals, so basically this is a slice right here, which means that animals is going to be multiple animals that are in a set of sorts. And this is going to loop over all of them. And then we get to do some logic inside of here. So we're just going to print. And then what we're going to do is we're going to print the method move so that we can see it in the console. And then for this to work, we got to like actually go down to our main function here and use it. And real world use case. Created a slice of mover which dog and cat both satisfy. We're gonna actually test it and break it in a second here as well. So we'll say animals for this is going to be assigned to a mover slice, and knowing that animal and dog both have the mover method attached to them because of what's happening right here. We're attaching this to the struct of animal. Then that should work. So mover and then dog, cat. And then we can print this. Okay, let's write it. Ooh, excuse me. Okay, so now we printed dog and cat. We printed the name and the age. Now I'm going to break this just to see. I know what it's going to do, but I'm going to break it anyways. Oh wait, what's the error here? Process animals. I did something wrong. Oh, no, that's my timer. That's my timer. That's my timer. Oh, I did this wrong. We need to actually do process animals because process animals will do the logging for me. Okay, I did that wrong. My bad, my bad, my bad. So process animals, and we pass animals into it. That's what we need to do. Okay, so we see cat is moving, dog is moving. Okay, cool. Now let us go and remove the addition of this method and see what happens. Okay, we can see here that mover value is an array or slice. Emerald is not pure. It does not implement mover. Okay, missing method move. Missing. Okay, so that's what I expected. That's pretty cool. I guess I can see how this would be a way to enforce or to ensure something is the correct type, or that it has access to the correct methods before using it in some later code. This could be good for like validation or to like protect the inner workings of something for type safety. Sorry, my little milkshake, my little. It's like between a milkshake and ice cream, but it's also just a protein shake. I just put too much ice in it. Sorry, I probably look so gross on camera. Okay. How far am I here? I think we should just take a break because it has been 30 minutes. I'm about halfway through this. Probably a little more than half. Well, no, no, no. I'm either halfway or a third. I don't quite know. The test part of this is going to be pretty easy. But you know what? I'm not in a rush. So let me go ahead and get off of here for a few moments. I'm going to try to guzzle down a chunk of this. Chunk is not a good word to use. I'm going to try to guzzle down a decent portion of this. And then I'll come back here in not too long. And then I'll continue doing this. So, yeah. If you're watching this, go ahead and fast forward. If you're not, take a break as well. Go get some air, take a walk. I'll be right back. Okay, peace. Hey y'all, what's up? What's Gucci? What's poppin'? We're back. Yeah, let's go ahead and get back into this. Before I move on, I want to reiterate what I just did before we left the stream for myself, for my own mental clarity, to make sure I really get it before moving on. So previously, I was looking at structs and interfaces, and I was just trying to understand the difference here. So a struct has fields, and a struct is like a type that allows us to organize fields that can be used to create new things of the type. So animal can be a cat or a dog as long as they have a name and an age. That's the distinction, but they have the same two basic fields. And then a interface here is I think the word was it a collection, a contract, or a set of methods. So in this case, we have just one method called move. The main thing is that in order for this, well, the way that this works is we have to make this interface and then we have to attach it to uh, some struct, so animal here. And then what will happen is that if we ever were to use this mover interface in the future, such as when we're typing an incoming argument for this function here, what will happen is that this mover interface will make sure that all animals, such as here, have this move method available in order to be used. So it's just a way to type check as well. So I mean, I say that and I understand what this is doing, but I know I'm going to have to come back and look at this later on in the future. So, and this is right here is the definition of the move method here. So, yeah, so we have the ability to attach it to instances of animals, but then we have the actual interface, which is what we would use if we're trying to ensure that some animal has this method uh, when it's being used. I think I could do a slice of animals as well as the typing too, but then a slice of animals would not ensure that it necessarily has this contract or this set of methods. It would only be able to ensure these set of fields. Can fields be methods? Is another question. Uh, that's a good question. I don't know. I'll just have to make a comment and maybe come back to this later. Can a field be a method? That's a good question. Okay. Um, what next? What next? Oh, okay. I think it's time for concurrency. Yeah, I think it's time for concurrency. So all of the concurrency I'm going to do is going to exist inside of a function. So I can go ahead and just set that up, and then I'll write the concurrency code and the actual function definition afterwards. So let's just get this out of the way first. I've never done concurrency before. I have a general idea of how it works. So I'm actually looking forward to this. Concurrency and pointers, I think, are the big things I'm interested in playing around with. I'm so excited, actually. It's odd because it seems like one of those things where it's like, chill, bro. Who cares? But I actually care. So this, in my notes, I have it as enhanced concurrency. But I've never done it before, so it feels weird to call it that. I'm just going to say demonstrating concurrency with Go routines and channels. And then we're going to call this function demonstrate concurrency. Concurrency. Okay, so before I get started, what do I think concurrency? So I believe that when you run code, for example, I wrote this Python script previously that allows me to create sine waves that run on different threads so that multiple sine waves can run at the same time. And I believe that that is concurrency when you have multiple processes that are occurring on separate threads happening at the same time. And I believe Go routines is the way that that occurs in GoLang. And I believe that channels is the way that you can communicate between two concurrent processes that are running at the same time. Oh, hey Siri, set a timer for 30 minutes. There we go. Okay, I almost forgot that. Okay, so that's what I think. Now, I don't know if my assumption is true. Now, let's go ahead and see if that's true. Let me go ahead and look this up in my little study session here. Let's look here. Run smaller components at the same time. Uh, okay, making processes on more than one task simultaneously with concurrency. I feel like I did this kind of thing with Reactive X or something like that. At the time, I didn't understand, but I think this is what Reactive X was when I did this at my one of my last jobs. It was like literally my very first job. This was like event streams and data streams. No, this is actually different. This is like sequenced operators operate on each item in the sequence. Okay, this is different. This is maybe something I should come back to. I don't know if this is still relevant, but I feel like I probably could understand this now. No, this is different. Okay, so okay, so maybe this is like unique. Well, no, it's not unique because I know that Elixir does concurrency as well. Okay. A Go routine is a function that is capable of running concurrently with other functions. To create a Go routine, use the word Go followed by function invocation. So right here, you put Go in front of the thing that you're using to call the function. This program consists of two Go routines. The first Go routine is implicit and is the main function. So the main function is a Go routine inherently. Okay, okay. The second Go routine is creating what we call Go with F and zero for its argument. Normally, when we invoke a function, our program will execute all the statements in the function and then return the next line following the invocation. Go routines we return immediately to the next line and doesn't wait for the function to complete. This is why we call a scan line. Okay. I don't think I fully understand this. Hmm. Hmm. Okay, so the first, let me reread this. Normally, when we invoke a function, our program executes all statements. A function. What is the scan line thing? Is this just a way to console log something that's happening in a Go routine? I've seen that pop up in the autocomplete, but I don't know what it does. Oh, oh, okay. It's just a way to get user input. I see. Okay. Yeah, it's just a way to get user input. Okay, let's just go ahead and create this, and then we can tinker with it if we need to. Okay, so I'm gonna make a function here called demonstrate concurrency, and first we're gonna make a buffered channel. I don't think I know. Oh, so the channel is the thing that is going to be used to store. Oh, we got to read the channeling thing here. Let me go ahead and take some notes and steal them from this. This is the book. Oh, I think this book is in my description. If it's not, I'll add it later on. But this is GoLang book. It's like a free online book. So yeah. Okay, so large programs, smaller. A Go routine is a function that is capable of running concurrently with other functions. And main is a Go routine. So the Go routine will return immediately to the next line and don't wait for the function to complete. So it's going to seem like everything is happening more or less at the same time. It's just not waiting for the next thing. It's not waiting for something to finish before moving on. I don't understand this part. Why this? I understand that it's saying to me that we need to do the scanline function, which takes in user input because the program will exit before the opportunity to print all the numbers. But it's not printing anything here. Wait, what is this? Okay, so this would print all the numbers. I guess maybe what it's saying is that we're using scanline because without waiting for it, we need a way to control when the main function stops, and that is by pressing some key. If not, the program would just automatically end as soon as it started, and there'd be no way to actually ensure that all of these prints happen. I think that's what it's saying. In fact, let me go ahead and I'm just gonna I'm just gonna paste this in. Honestly, I can undo it. It's gonna be a little messy, but I really just want to paste this in here and see. Let me comment this out and just see what happens. Oops. Okay, so now it's waiting for me to do something, and we're just gonna do it. Okay, so I think that's what it is. Let me get rid of the scan line part and then run that again. Let's run that again. Yeah, so it wasn't able to actually do all the logs because the program ended before I got to do it. So I wonder what happens to those processes when they're not able to log. Like, do they just, is that what trash collection is doing or something? And I really don't know. Well, that's interesting. Okay. I feel like I understand that now. So this shouldn't be too hard. I don't quite know the situations when this would make sense to use, but I'm sure that for the idea I have in the back of my head that I want to do in like a few months, it'll probably make a lot more sense. Okay, so the last thing here is channels. What do channels do? Channels provide a way for two Go routines to communicate with one another and synchronize execution. Okay, cool. That's cute. That's adorable. It's a relationship goals. All that. Let me make this into a star. Okay. So we got this is the channel maker. I don't understand this syntax. Okay, this is the printer. The message is going to go from the channel to this message variable. And then here, let's just go ahead and write my code. I really don't know where this is going, but let me just do it. Okay, so this is going to hold the channel, the buffered channel. So we're going to use make chan string, and then we're going to, I guess we're making one. What is the make method or function? What's the buffer capacity? Oh, so the buffer part of this means it can hold something. Otherwise, it can only send something. Okay, so you could use the channel, and the channel probably has methods for sending things, and you could customize those, or you could actually receive something to the channel and hold it there to be used later on, is what I'm getting from this. And so if they're full, they're blocked. Okay. Okay, cool. So we'll be putting things in the buffer channel. What is it called again? The buffer um, limit. Oh, the capacity is what's called. The capacity is the number of messages. Is that what it's called? I hate this little pop-up. Number of values. So it's the number of values it can hold before becoming full when it is after which it is blocked. Okay. Okay, cool. So within this, we're just going to make an anonymous function. It seems like, um, so go, I've actually never made an anonymous function GoLang before. That's how new I am. So we're going to use the time dot sleep. This is going to cause a delay, time dot second. Excuse me. It's like 10:11. It's not super late, but I am pretty tired actually. Okay, so it's just going to complain. Expression and go must be a function call. Oh, I gotta call it. So if you make an anonymous function, you actually have to call it. That makes sense. This is like in JavaScript, we do like this, and this is defining a function and running it on the same line. Inside of GoLang, that's this equivalent. So let's just put a comment here. Which runs after which is executed at the place where it is defined. Okay. Okay, so what we're gonna do here is like after waiting a second. We're going to send a message to be stored in the channel. And that is what this go routine is doing. This go routine will wait a second and then send okay. Cool. Now, I don't know what select does. So what's next? Next. Select. Select lets you wait on multiple channel operations. Combining Go routines and channels with select is a powerful Go or feature of Go. So we're saying here, this is a Go routine. Okay, so Go routines are like anonymous functions that can run on their own, but I'm assuming that Go routines can also be defined in front of a regular function. Assuming. I don't know. Okay, so this is what we're doing right now. This is another one, and we're sending these as two separate channels, and then this select is going to send. It's going to capture the message from the first channel into this variable and print it. And it's also going to take the message from the second channel and print it as well. So this is not a switch like a condition. How is this I being used here? That part's confusing me. I 0 while I is less than. Okay, so we're just forcing it to run twice. I don't understand. Okay, this kind of makes sense, but each channel will receive a value after some amount of time, simulating blocking RPC operations. So I guess that's what we're trying to see if it. We're trying to see the blocking behavior by doing it twice because channel can only hold one message. Maybe I don't know. Will you select to await both of these values simultaneously, printing each one as it arrives? Okay. So select is just a way to await the receiving of a message from a channel. And then these cases are just a way to define where they're being stored. And then you can do some functionality underneath it to utilize that message. And I don't know why this is running twice, like why that's needed necessarily. But at least it makes kind of some sense right now. I kind of want to run this. You know, I'm going to be foolish right now. I'm going to be real foolish and just do something real extreme. Let me just go ahead and do Command A. Let me commit this first. I'll let me destruct. Let's just say, uh, let's just say, interfaces structs and partial coroutines. Okay, I'm going to be real distracted. I'm literally just going to paste this into my code real quick and replace my code and then run it. Now, what happens if I take away this for loop? So it won't, so it won't, so it'll only stop, it will stop after the first one. So the for loop is necessary because the first time this gets fulfilled, I guess, and the second time this gets fulfilled. So maybe there's some type of like order. What if I were to change the times here? Would that, I guess that would probably still matter. Oh, so this message got fulfilled first, and then this one never got fulfilled. So the order matters. The order in which they're supposed to be received matters, and it can't go back. That doesn't. Oh, I see what's happening here. Let me undo this. So, okay, so I think I know what's kind of happening. Okay, so what's happening here is that you need to loop. So every time you go through this, the select will only work on the first thing message that is like received. It only works on the first one that is received. Um, so you have to run this select every time you want to receive a message. So I don't know. I can't express it. It's interesting. Let me just do my example, and then maybe I'll have to come back and do Go routines again for another live stream. I'm cool with that. This is really my first time, anyways. Okay, so let's go ahead and write our select. The select, and then we want to do case. We want to store a message, and we want to assign it such that it receives from our channel. Um, is there a space? There's no space. This is so weird. I feel like I'm writing an alien something or rather. So we're going to receive the message from the channel, and then with that message, we're going to do fmt.print. Print. Received. And then we're going to put the message in here. And then we need another case as well. And then this case is going to I think that there is a message. Oh, I see. Okay. If there is no message received after 2 seconds, then we want to print a message here that will say time out, no message. Um, After 2 seconds, the time. So I guess this will have a channel, has a channel. Oh, after waits for the duration to elapse and then sends the current time on the returned channel. Okay. What if I store this in a variable? and just put time here. I'm curious what happens. Let's get rid of this message here, so it'll never have a message. Oh, okay. So it's kind of like a switch statement, except instead of observing for a value to match, what this is doing is just waiting to receive a message. And any of these messages can work. It'll just simply respond to whichever one it gets. And then if we have the loop running here, the loop will obviously receive this one first, but then the loop will run again and it'll wait to receive the next thing and it'll happen to be this. But there's no reason why we couldn't call the same message. It's just that every time this message calls, that counts as an iteration. So that's going to initialize this loop to restart. Okay, that makes sense. So let's write a note here. Select is kind of like a switch, except instead of matching a value, it will wait for a message to be received. So the message could exist here. It'll be listening basically. The cases act like listeners for channels, and then do some behavior once the message is received. The message is stored in a variable. Okay, that makes a lot more sense. Yeah, I like that. I like that. So basically, like if I were to make a game, what if I were to make a game and I wanted to be able to have two different players doing things and have their own separate processes so that they're not blocking each other or like using the same resources. These two players could do things that could have interaction between them, and I could simply have a channel that these player behaviors communicate to. This is kind of giving me the vibe of what's it called? The messaging service stuff. Let me see. Is it called SMS? Not SMS. SQS and AWS. It's kind of giving me the vibe of like a queuing service where like in cloud infrastructure, you have like microservices running in a big cloud, and then you have like one central place to store messages, and any of these services can connect to that messaging services to receive information, which could be coming from other microservices like data or status or that kind of thing. Is it called S? There's another one. It's SQS and there's another one. I always get them mixed up. Um, Messaging. Let's look it up here. I don't. This is a little bit of a tangent, but I'm curious. Um, is it SNS or SQS? What is SNS again? I forget. Simple notification service. I feel like that's what I'm thinking of. Yeah, publishers and subscribers. It's kind of giving me this vibe. Like you have a publisher, which is a thing that can produce a message, and you have subscribers, which will receive messages from the central publisher. They all share one publisher, but they can all receive the same message. So they all kind of know what everybody else is doing, or to some degree, they can. They can know what everybody else is getting. And then there's the SQS. What is that again? Simple queue service. I always get these. I didn't use them enough to like have a strong idea of them. Um, Send, store, and receive messages between software components. I could maybe this is the one. Send, store, and receive messages between software components at any volume. This is how you can communicate between two different microservices. I think this is what I'm thinking of. So yeah, these channels are giving me this vibe. Okay. We got two more things left. I'm gonna try to knock one of these out. The next one is going to be just some more error handling. This should be real quick, and I'm gonna take a quick break and come back, and we're gonna do some testing, and I'm gonna get off of here. It's been an hour and 30 minutes. Okay, so oh, my timer's going off. Look at that. Actually, let me go ahead and respect my timer. I'm gonna take a break right now, and then I'm gonna come back, and I'm gonna do the error handling. Let me go ahead and just set this up so I can get straight to it. All right, I did error handling in the last one, but I feel like this is just something I'm going to have to keep practicing because it is just a different pattern than I'm used to. Okay, so I'm going to be back. Give me like 5-ish minutes or so, and then we'll knock this out. Okay, be right back. Hey y'all, I'm back. Took a little longer than I thought, but ain't nobody watching my stream no how, no way anyways. So I can do what I want to do. Okay, let's get back into this. Let's knock this out and then we can be done. Okay, so where I was before, I was playing around with concurrency and basically I learned that you can make these little go routines, and they're basically functions that will run independently. You can have more than one of them happening. They all happen at the same time on their own thread, and we can use these, and we can have a message basically happen at the end of this routine running, and this message can be stored inside of this channel, and then these channels can communicate, these channels can allow go routines to communicate between one another. I don't know exactly about that particular part, the last thing I just said, with go routines communicating to one another, but I do know they can send messages to like a central place or to central places, if you will. And in my mind, I'm thinking it's similar to how like in microservices there's like SQS. I know that they're different, but that to me kind of seems like an analog. That's where my mind is using right now to kind of understand it. So I'm definitely going to revisit Go routines. I want to come up with like a little project or something that's going to utilize all of these things in a much more practical way, rather than just like doing these little exercises. But I'm working toward it. Okay, so okay, next thing here is I'm going to do another error handling. I think the dividing by zero, like I did last time, is a good example. So I'm just going to recreate that. So print line, and this is going to be, make a new line here. Error handling. Okay, so what we're going to do is we're going to make a function called divide numbers. And we're going to take in two numbers. One is going to be called x, and the other is going to be called y. Y will be a float 64. Now, I don't know why it's recommending float 64. We're going to end up trying it without it. I don't think it matters. And then the return type of this function will be, oh, I know why. I think it's because when you divide, division actually gives you a float, because division in many cases will never be another integer. That's probably why. I don't know that for sure, but that makes a lot of sense. So it's probably the default type for division operations. Okay, so this could either give us a float 64, which means that it happened successfully, or this gives us an error. And the way that error handling happens in GoLang is like you have to have an if statement. I did read that there is no try catch in GoLang like there is in JavaScript, and Python has a try catch too. So that is interesting. I don't know why that design is like that, but it does make this a little bit more verbose. So the way that this works is we say if y, which is the denominator, is 0.0, then that is an error. We're catching that before the error actually happens. Otherwise, I think we'd have to do a panic or something. I don't think a panic. I think a panic would be created for us, and that would actually cause the whole program to break or to not run. So this is us knowing what would cause it to break, and then preventing it, basically. So return. We want to return 0, and we also want to return the error, an error message to print to a console. Okay. And then if this does not happen, then we're going to return the, we're going to let this evaluate out, of course, and then we're going to return nil, and nil it's not going to do anything. So we need an escape character here. Okay, so cool. So we should be able to use this now. let's go ahead and capture what we want to do is we want to capture these two things here, regardless of what happens. And then we want to store them. So one's going to be the number, and the other's going to be whether or not there's an error. We want to store them in variables by destructuring. Oops, I'm being real sloppy right now. Divide number, and we're going to do 10. And let's just start off with 10 and 2. So that will give us 5 and nil. And then we want to fmt.print line, and we'll say result of division result. We'll do the error thing here in a second. Let's just make sure that this works. I think I can do that. So if you want to have a variable that is not used, you just make it into an underscore. Okay, so that's 5. That works. So we want to make a condition here that will handle if there is an error, if this error ERR actually has a value. Otherwise, we'll get this error here that says we're not using it. We'll get this right here, declared not used. GoLang is really, really picky, by the way. I'm sure that's a good thing, but it is very picky. Picky of the JavaScript. I think everything's picky of the JavaScript except maybe Python. Okay, so nil. If it is not nil, means that there is an error. There is an error. And then in that case, we want to just fmt.print, and then we want to just print the error. Like that. So this is just gonna tell us what to do when there's an error. Let's run this one more time. Okay, we got no errors here. And then let's go ahead and make this 0 so that this will actually give us this error message, and also give us this from our function here, actually give us this right here. So error cannot divide by 0, and then you can see here that it still will give us this last print. Okay, so that basically is the end of this. Now the last part here is I'm going to actually make a test file and go. Oh, excuse me. Ooh, child, please. Am I okay? Ooh, that a little milkshake, a little protein shake got me burping. Okay, so in GoLang, you can do testing, and testing is built into GoLang. Thank goodness, because I like. Okay, I'm gonna say I like testing. That's a little exaggerating. I don't mind testing. My one reason why I don't really do it in JavaScript and Node is because it just is a hassle. There's just something about having to do it in JavaScript that even in TypeScript where it's just like, ooh, this is too much. It's too much going on. And it just really causes an aversion. But it seems like GoLang is like trying to keep it cute and classy. So I'm gonna do it. I'm not gonna go into my GoLang lifestyle without testing. Okay, that doesn't even seem smart. Okay, so I have some notes here. The first thing is that there is a file naming convention for GoLang that identifies a file as a test file, and it is. Let me do this in terminal. So touch, and it is to do the name of the file that you're testing. So we're going to test main, and then you have to do underscore test. So this suffix here, test, is what allows us to identify this as a test file, and then we do .go. I actually have some notes here. I'm just going to go ahead and put these in here. I feel like that is fine. Okay. So test files in Go are named after the file they test with a underscore test suffix. For example, main Go would be main test Go. Test function naming. Test functions must start with test, followed by a name that describes what is being tested. The function should take a single argument, t, with a pointer to testing.t, uh, which is a pointer to testing.t. I guess testing.t is a something in memory at this memory address that GoLang must produce. I'm not really sure about that part. Oh, I see. I see what's happening. We have to actually import testing. So let's declare a package first. So this is going to be package main, and then import testing. Okay, so this testing thing is existing in it's a pointer to a location in memory basically, and this testing IT is a pointer to some location in memory, and we're going to be using it. We're going to be using it, I guess. Oh, this seems pretty straightforward. Okay, I think I get this. Um, so running a test. Also because this shares the same package as this file that we're testing, that means we will have access to like our interfaces and structs and whatnot as well. Yeah, that's pretty cool. Oh, okay. This command will, and then the command to run this will be go test. This command will run all tests. There's a way to like run specific tests. I'll tinker with that at the end. So let's make a test for this animal struct that has the method of speak on it, and we're going to test that the correct animal has the correct um, speech. Okay, so func test speak, and then we'll do t pointer testing.t. Okay, this is a test state. Cool. And then let's say dog, animal, name, dog, age, 5. And let's do cat, animal, name, name, and let's do cat, age, and then let's do 3. And these need to be curly braces, my bad. Okay, so we've made a cat and a dog using this animal struct. Oh, that's cool. So when we hover over this, we can see the methods are available. Okay, cool. Um, so now we're going to make the dog speak. So dog speak equals dog dot speak. And then here's our test to confirm that the correct output from the speak method occurs. If dog speak is not equal to wolf here. Then we're going to do t dot error f. This is going to be what happens if this test fails. Expected dog to say wolf. Got, okay, and then we're gonna, this is like a formatted error message, so we can do, we can inject something here. Got %s, and this is going to represent dog speak. So this is what actually, um, this is what it gave. It wasn't giving what it was supposed to give. This is what it gave instead, basically. Did I spell this wrong? Dog speak? What's going on here? Um, what? Undefined? Oh, huh? Why is this breaking? Dog speak. If dog speak. That seems weird. Here it is. Undefined dog speak. That seems strange. Oh, I know I did wrong. Because I didn't put the colon here. It's not a declaration. It's not a full declaration. It was waiting for me to put like var or something. Okay, so that passes. Let me change this. I want to see the test fail. Always make sure your test could fail. Okay, so cool. Okay, let's do this again. We're gonna do it for the cat. So cat speak and cats cat dot speak. Cool. Cat speak is not equal to Mew Mew. Then t dot error f, and then we're going to say expected cat to say Mew Mew. Got. I need like a keyboard that has an actual, I need a keyboard that has an actual numpad on it, to be honest. I have one, but I only have one, and it's in my job. And I love having it there because it makes it easy when I'm trying to like code for students and everything. By the way, let me just say this. I love being a teacher. It is the perfect career for me. Um, and that keyboard, having a good keyboard as a coding teacher, I'm going to just say that that is everything to me. Okay, so we're going to run go test, and I can see that both my tests pass. I didn't make this test fail real quick just to make sure. Okay, cool. This one right here is telling me that something in test speak failed, and then also this is the particular test that failed. Um, wait. Oh, okay. Yeah, 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 yeah. Okay, cool. Let's just go ahead and undo my little error here and make sure this passes again. Oh, I gotta comment that out. Okay, cool. So it's saying everything here is good. Gucci, Prada, wonderful, thunderful, thunderful, but definitely not blunderful. Okay, quick break. Not a break from this stream, but I want to look into something here. There is a way to run specific tests instead of the whole file. What was that again? There's a way to do that. Go test command. Oh, I could probably do go test help. Is it go test test flag? Um, okay, this is not what I was wanting. Um, oh, you can provide like testing and stuff. That was cool. Okay. These are different flags for Go test. These are not what I'm looking for, but it's interesting that these are all here. What does the test func look like? What is this? What is this, like an example? Okay, that's not what I'm looking for. Um, so Go test main dot go. Okay. Okay, so I could run a specific file. Hmm. I think I could give it the name of the test here. So test speak. I think I could do that too. I guess I can't. Oh. Okay. It's assuming that that is a test file and it doesn't like that. Oh, so since this is a package of main, I think I can do go test main. What? Why, like, hmm. Oh, If you want to test a certain file with its test file, you have to do this. Oh, well, we can do go test dash v. That's nice. This is what I actually would prefer to see. Um, okay, so I'll use dash v in the future. But then, okay, so here you have to actually give it the name of the file and the test file. So go test main.go space main test.go. Okay. Okay, why can't I do main? Hmm. That's how you run a specific test. I don't think I like all that. That seems a little funky to me. Okay, I'm gonna have to revisit this. This seems like one of them things where I might have to make my own scripts. Let's try cover. Go test cover. Oops. Oh, okay. So, okay, that's interesting. That's coverage. I'm really just skimming this, to be honest. Um, oh, let's try this. That's cool. Hmm. I like this color coded thing here. I'm gonna have to come back to this because um, having some better looking stuff going on would be nice. But at the same time, I don't want to deal with this HTML stuff. Hmm. It's saying we need to have this file. So I'm just gonna wing this, and if my assumption here is not correct, then I'm not gonna spend too much time doing this. So let's just make a file here. Okay, and run our. Oh, that did work. Okay, um, it kind of worked. Now I have to get the actual um, okay, so this right here is going to take the coverage profile and put it in here. Oh, okay, I have to do, okay, let's try this. Okay, so that will put the coverage output in the file, and then I can run this tool to open it up in the browser. Oops. This tool to open it up in the browser. Why didn't it copy? I gotta do it this way. Like that. Okay, and then this is going to tell me exactly what is not being covered. That's actually nice. Gosh, 100% coverage is daunting, I will say that. Okay, well that's cool. Now I might need that in the future. Okay, so let's write another test function here, and then we'll be done. Oh, that was my timer. Let's test the move method. So test move, test the move method of the animal struct. Func test move. T, we need to point it to testing.t. And then animal is going to be assigned to a new animal called bird. And the bird is going to be 1. And I keep making these parentheses. These need to be curly braces. And we need to store the animal.move in a variable. What does move do again? Oh, it just says the animal name is moving. Okay. It's very simple. Okay. And then, well, we need to have something to store what we're expecting. I'm expecting this sentence here. So expected, oops, I messed up. So expected to be bird is moving. And then we need to write our actual test. This is like an assertion. Assertion. If move is not equal to expected, that means our test has failed, in which case we do t.error, which is formatted, and we're going to put in here expected s got got s. And then we can inject expected for the first formatted interpolation. I guess that's interpolation. And then second one there. Okay, so let's go ahead and run this. This should pass. Oops, wrong command. This can be go test. This failed. Okay, we had a lowercase here. So let's fix that. And let's see now. And everything passes. Woo! Okay, well, that is that. Oh, we could also do this here and run the individual tests, by the way. Um, oh, oh, what? Oh, I see. I think this has something to do with my Go mod or something. Wait, package GoLang intro. Where is that? Because I changed the name of that. Sorry, this is something else. Uh, GoLang intro. Why is it saying this though? Um, it's treating it like it's the package of the. This is a separate thing, but I don't know why it's doing that. Let me um, let me reload this real quick. That might be another issue I gotta figure out later on. Okay, there we go. It was using the package name for something else. I think I did something weird when I was uh loading up this file. Now it's working. Now it's using intro 3, which is the name of this module. Okay, so that's cool. We can run individual tests just through the GUI here. That's nice. There's no issue with me. I'm gonna go ahead and commit this. So let's just say done and tested. And let's pop that up. If you're interested in this code, all you have to do is go down to the comment section. The link is already there. I added the link and I just committed and pushed this up. So if you're interested, go check it out. You can see here just now committed this. This is the same code I was just working on. If you want to see these formatted comments here, just go to the extension store and get better comments, which is this one right here. This will allow you to see the colored special formatted comments. Otherwise, they'll all be gray. So yes, I think that's pretty much the end of what I got going on right now. It is 11:16. I need to go rewatch an episode of this TV show that I've been really into lately. And also it's Friday, so I'm gonna get me some good old sleep because I got things to do this weekend. So I'm gonna let that be what it is. Let me get you over here with this little. By the way, my little mascot here, my little theme is mice. You're gonna see a lot of mice. I got this mouse right here. I have this one right here. And also I got this one right here. I got this little dude right here. It looks like a koala actually, but it's a mouse. So I don't know. I think it's a cute little theme. These images are made with Midjourney. So that's neither here nor there. I'm just rambling at this point. Let me go ahead and get ready to get off of here. Inspirational messages. You know what? I heard someone talk about. Oh no, who was it? It was Andre 3000. I watched an interview with Andre 3000, and it was about his Woodwind album that he recently released. And I'm a fan. Andre 3000 is like my generation, and something that relates to what I'm doing here on this channel that he said that I really appreciated is like it feels good to be a baby at something. Especially when you have been doing something else for a really long time, sometimes it can no longer feel like you anymore. What he was saying was like he was a rapper for so long and that was like his thing. It was what he was known for. But as someone working with a new type of music, the woodwind instruments or whatever, it's like a chance to experiment and explore and watch his learning process, and that the album that he made is really a documentation of that process of him stepping into this new thing. So to me, the way I internalize that with this stream is like I'm not a master by any means of any stuff that I've done in the past. um I would say that I definitely have proven myself to be skilled and employable with those technologies and stuff like Node, React, um, AWS, TypeScript, just all that kind of stuff, SQL. I've had work doing those things. Never consider myself a master though. But what's nice about this is like I feel like I get to be a baby again. And I love that journey of I love the learning curve that happens. I love seeing the blossoming of a new skill set. And I do want to take it beyond just that. I do want to go to mastery with this. Maybe not this specific language, but like with my ability to code and understand software engineering concepts in general, I want to go to mastery. But I think as a part of that, you have to appreciate the newness, the white belt, the beginner's mind. Those are all things that you actually need in order to become the master of your craft. And your craft is a broader territory. If you only do one thing and you never do anything else, that could be fine for some people, but that's just not really what I want. And I would encourage you to be okay with that feeling that you're not an expert at something. Um, it is a beautiful and humbling experience to try something new and to just simply accept that you don't need to be amazing. You know, it is a privilege to be able to experience that without rushing and to really be able to savor that journey. And don't rush by it. Live in the moment, live in the enjoyment of what you're doing, embrace it for what it is. Don't judge yourself for where you are in that journey. Life's pressures aside, because sometimes that's real. Sometimes we do things because we need to, and there's like this uh, crisis we would have if we didn't really push ourselves in a certain way. But if you at all have the capacity to just slow down and enjoy the journey, I highly recommend doing that because you only live once. And when you go into a skill set, usually that early journey is a very unique experience that you cannot go back on. So when I make these videos, I think what I love about it, just like Andre 3000 was saying in his interview, is like it's not even the fact that people are watching my stream. I think the most views I've had up until the point of this recording is about 111. And before that, it was like 30 something, right? So maybe if I was like back in my former years where I really wanted to like be more popping in a little social media, maybe I would have cared more. But now at this point in my life, I love just simply being able to look back on things 6 months from the time, a year from the time, 2 years, 3 years from times. There are some videos that are on this channel that I have privated or hidden, and I love looking at them because it's just like hearing myself talk about things, hearing myself have intentions, and actually seeing which ones of those that I pursued and succeeded in. Seeing myself. There's a video that I have that maybe I'll bring it back one of these days. It's like me at the very beginning before I even went to boot camp, before I even got my first job, before I even knew what full stack meant. Um, talking about how I wanted to go to this like school and I want to have a program, I want to make apps, you know, and just like stuff like that. And I think if I could change one thing, it would be that in the journey, I wouldn't have rushed so much. I kind of had to because of my circumstances, but I wish that I would have just been more in the moment and present with the newness of it all, the beginner's mind, you know, because it really is. It's beautiful to observe someone in that space, although we oftentimes don't feel that beauty when we're the ones in that space, if that makes sense. And I want the best of both worlds. You know, I want to be able to enjoy the beauty of looking back in hindsight, but I also want to, if anything, become a master of present mindedness with myself in these types of moments. And I call it the struggle zone because that's what it feels like. But the struggle zone is also the space of magic when it comes to growth and development of your character. The struggle zone, if you learn to master the struggle zone, you learn to enjoy it, to exist, to self actualize within it, you're a powerful creature, you know. And so this repeated exercise of going back to white belt. I'm a martial artist in my spare time, so that's another way I interpret this. Going back to white belt, going back to white belt, going back to white belt. That is a journey that is worth taking towards mastery. You're getting something out of doing that. So I'll leave you with that. That's my philosophy. That's my falafel. That's almost said. I'm a little tired. That's my philosophy. That's my soapbox. That's my ramble. That's my rant. Thank you for coming and watching part 3. I've done 3 videos this week. I was not expecting that. I don't know if this will be the pace. We'll just see what's happening. The winter break's coming up. Never know. I'm definitely going to do some stuff with C Sharp at the end of the month, like the last 2-ish weeks at somewhere around there. I'm gonna do some C Sharp stuff in a different playlist. So stay with me. Watch this. Watch the next one. Just go ahead and subscribe. Give me a follow. Go ahead and comment. Do whatever you want to do. Share a video. Go crazy. Go bananas. Go bonkers. I love you for it all. Okay, I'll catch you later. My name is